Humanity has always gazed at the stars and wondered, what lies beyond? Are we alone? The universe teases us with mysteries that challenge our imagination and science. Today we embark on a journey, not across space but into its greatest enigmas. We'll visit black holes, search for other Earths, and question the very fabric of reality. These are the questions that define our place in the cosmos and push us to explore. Here are the 10 greatest unsolved mysteries of space. Black holes, regions where gravity is so intense not even light escapes, remain the ultimate cosmic riddle. At their core, our theories predict a singularity, infinite density, zero volume, where physics breaks down. But quantum mechanics and relativity clash here, hinting at a deeper, undiscovered law of nature. Some propose black holes are tangled balls of energy or even gateways to new universes. Could our universe have been born from a black hole in another cosmos? Black holes may be not just destroyers but creators, engines of cosmic rebirth. The moon's surface is littered with odd shapes, towers, shards, and castles that spark wild speculation. Science explains most as tricks of light, shadow, and geology, but some anomalies remain stubbornly mysterious. Are these just rocks, or could they be ancient artifacts from a lost civilization? While evidence is lacking, the moon's secrets keep us wondering what or who came before us. Sometimes the line between science and imagination is thin, and the moon keeps its secrets well. Among billions of stars, could another Earth be spinning in a distant Goldilocks zone? Telescopes like Kepler and TESS have found thousands of exoplanets, some rocky and Earth-sized, orbiting in habitable zones. The next step, probing their atmospheres for signs of life, oxygen, methane, water vapor. If Earth isn't unique, the galaxy could be teeming with habitable worlds, maybe even superhabitable ones. The search for another Earth is a search for ourselves, and for cosmic company. Are we just one of countless thriving worlds? The Fermi paradox asks a haunting question. If the universe is so vast and the ingredients for life seem to be everywhere, why do we see no signs of other civilizations? With billions of stars in our galaxy alone and countless planets orbiting them, it seems almost inevitable that life should have arisen elsewhere. Yet, when we look out into the cosmos, we are met with a profound silence. No signals, no evidence, just the quiet expanse of space. This mystery has puzzled scientists and dreamers alike for decades. The Great Filter theory offers a sobering explanation. It suggests that somewhere along the path from lifeless matter to advanced, spacefaring civilizations, there is a nearly insurmountable barrier. A step so difficult that almost no life ever makes it past. This filter could be behind us, or it could still lie ahead. It's a concept that forces us to confront the possibility that intelligent life is incredibly rare, not because it doesn't try to emerge, but because something almost always stops it. Maybe the filter is the leap from non-living chemistry to the first self-replicating molecules, a transition so improbable that it has only happened once in the observable universe. Or perhaps it's the jump from simple, single-celled organisms to complex, multicellular life, which took billions of years on Earth. Each evolutionary milestone, intelligence, tool use, language, could represent a hurdle that most worlds never overcome. But what if the Great Filter is still ahead of us? Perhaps the real challenge is surviving our own technological adolescence. Civilizations might develop the power to destroy themselves, through nuclear war, environmental collapse, or runaway artificial intelligence, before they ever master interstellar travel. The silence in the cosmos could be the echo of countless societies that reach this point, only to vanish before making their mark on the stars. The universe could be littered with the remnants of failed civilizations, a cosmic graveyard of worlds that once teemed with life, now silent and empty. Or perhaps there are dangers we can scarcely imagine, cosmic events like gamma-ray bursts, or predatory forces that eliminate any species bold enough to announce its presence. The silence might not just be a warning, it could be a sign that something out there is watching and waiting. So, where does that leave us? Are we the first civilization to make it this far, standing on the edge of the Great Filter, or are we simply the next in line to face it? The uncertainty is both thrilling and terrifying. Our choices in the coming centuries may determine whether we become a beacon of life in the universe, or just another silent world among the stars. The answer to the Great Filter may ultimately decide our fate, not just as a species, but as a potential voice in the cosmic choir. Will we endure, or will we fade into silence? The future is unwritten, and the universe is waiting for our reply. We can trace the universe back to the Big Bang, that moment nearly 14 billion years ago when all space, time, matter, and energy burst forth from an unimaginably hot, dense state. But what about before that? What, if anything, existed before the universe as we know it began? This question has fascinated scientists, philosophers, and dreamers for generations, pushing the boundaries of our imagination and our understanding of reality itself. Some physicists argue that the very concept of before the Big Bang is meaningless. According to Einstein's theory of general relativity, time and space are intertwined, and both began at the Big Bang. In this view, asking what happened before is like asking what's north of the North Pole. There simply is no before for us to consider because time itself didn't exist yet. The universe and time itself had a beginning, and anything prior to that is beyond our current scientific reach. Yet, not everyone agrees. Some cosmologists propose that the Big Bang was not the absolute beginning but rather a transition, a bounce from a previous universe. In these cyclic or oscillating models, the cosmos undergoes endless cycles of expansion and contraction, with each Big Bang marking the start of a new era. In this scenario, our universe could be just the latest in an infinite series, each one giving rise to the next in a grand cosmic rhythm. String theory, one of the leading candidates for a theory of everything, offers another mind-bending possibility. It suggests that our universe might be a three-dimensional brain floating in a higher dimensional space. According to some versions of this theory, the Big Bang could have been triggered by a collision between our brain and another, unleashing the energy that created our universe. In this picture, what we perceive as the beginning is just one event in a much larger, multidimensional reality. And then there's the idea of the multiverse, a vast cosmic foam where countless bubble universes, each with their own laws of physics, are constantly forming and fading away. In this scenario, our universe is just one bubble among many, and the Big Bang was simply the birth of our particular bubble. The multiverse could be eternal with no true beginning or end, and our universe's origin just one of countless others. These ideas challenge our deepest assumptions about time, space, and existence. Our beginning may be just one of countless beginnings, each with its own story, its own mysteries, and its own possibilities. The more we learn, the more we realize how much remains unknown. The true origin of everything, the ultimate answer to what happened before the Big Bang, remains one of the greatest mysteries in science. Perhaps one day, with new discoveries and deeper understanding, we'll get closer to the truth. Until then, the question continues to inspire wonder, curiosity, and the search for knowledge. Fast radio bursts, blindingly powerful, millisecond-long blasts of radio waves, erupt from billions of light-years away. Their origins are unknown, colliding neutron stars, magnet or starquakes, or something stranger. Some FRBs repeat, hinting at a stable, mysterious engine. We've traced a few to distant galaxies, but the cause remains elusive. Could they be signals from advanced alien technology, a galactic beacon or propulsion system? Until we find a natural explanation, the possibility lingers. The universe is sending us messages, we just don't know who or what is speaking. Imagine everything you've ever seen, every star, planet, and galaxy, every atom in your body, and every object you've ever touched. All of it together makes up just 5% of the universe. The rest is a vast, invisible realm, hidden from our eyes and our instruments. This mysterious majority is made up of dark matter and dark energy, two of the greatest enigmas in modern science. While dark energy is responsible for the universe's accelerating expansion, dark matter is the unseen glue that holds the cosmos together. Dark matter, which accounts for about a quarter of the universe's total mass and energy, cannot be seen or touched. It doesn't emit, absorb, or reflect light, making it completely invisible to telescopes. Yet its presence is undeniable. We see its fingerprints everywhere, in the way galaxies spin, in the way clusters of galaxies move, and in the subtle bending of light as it passes through massive cosmic structures. Without dark matter, galaxies would fly apart, unable to hold themselves together. It acts as a cosmic scaffolding, shaping the grand architecture of the universe. When we observe distant galaxies, we see light bending around invisible masses, a phenomenon called gravitational lensing. This effect reveals the hidden presence of dark matter, tracing out a vast cosmic web that connects galaxies across unimaginable distances. For decades, scientists have searched for the elusive particles that might make up dark matter. Deep underground laboratories shielded from cosmic rays, house sensitive detectors designed to catch the faintest hint of a dark matter particle. Yet despite years of effort and increasingly sophisticated technology, these experiments have found nothing. The true identity of dark matter remains hidden. Some physicists have begun to wonder if our understanding of gravity itself needs to be revised. Could it be that the laws written by Einstein, which have stood for over a century, are incomplete? Perhaps the answer to the dark matter puzzle lies not in new particles, but in new physics. What we do know is that dark matter forms a hidden skeleton for the universe. It weaves an intricate network of filaments, connecting galaxies and clusters into a vast cosmic web. This invisible structure shapes the evolution of the cosmos, guiding the formation of stars, galaxies, and even the largest structures in the universe. As we gaze into the night sky, we are surrounded by the unknown. The quest to understand dark matter is a journey into the deepest mysteries of existence, a reminder that, even after centuries of discovery, the universe still holds secrets waiting to be revealed. What if advanced civilizations build megastructures like Dyson spheres to harvest their star's energy? Tabby's star, with its bizarre irregular dimming, sparked speculation. Could we be witnessing alien engineering? Natural explanations, comet swarms, dust, shattered planets, fall short of fully explaining the data. While most scientists remain skeptical, the idea of alien megastructures forces us to expand our search for life. Sometimes the shadows of intelligence may be easier to spot than its signals. The universe may be full of wonders we're only beginning to imagine. The universe is expanding, and shockingly, that expansion is speeding up. Dark energy, a force we barely understand, is driving galaxies apart faster and faster. It makes up most of the cosmos, yet its nature is a complete mystery. Is it a property of space, a dynamic field, or something else entirely? The fate of everything, endless expansion, collapse, or a catastrophic big rip, depends on the answer. Our ultimate destiny is written in the stars, but the ink is still invisible. The universe's future is as mysterious as its past. Are we alone? The search for life beyond Earth is a quest for cosmic context. We hunt for habitable exoplanets, listen for alien signals, and analyze distant atmospheres for biosignatures. Life could exist in forms we can't even imagine, on icy moons, in methane lakes, or as planet-spanning networks. Some theories suggest life is common, seeded across the galaxy by comets and asteroids. We may be part of a vast, interconnected galactic biosphere. The answer could redefine our place in the universe. We've explored black holes, the moon's secrets, other Earths, and the fate of the cosmos. Each answer uncovers deeper questions, reminding us how much remains unknown. Science is an endless journey into the dark, driven by curiosity and wonder. Which mystery, if solved, would change everything? The universe is waiting. What will we discover next?